So this is a topic that was not born out of just, a presentation material piece, okay? This is something that I put into practice in the real world every day. And so I just wanted to, intro that, and then we'll just kind of dive in here. So this is me. I go by Steven. If you're my sales director, I go by Steve Marino. Any name that you want to call me, I'm fine with that. Admittedly, that's a pretty old pic of myself. So once you turn 40, it's kind of hard to look at yourself and you kind of dive back about 10 years trying to find a picture of yourself that you're happy with. So a little more hair than I have now, but not that much. So many of you may not know who I am, but you might know the company that I work for, which is Saline Consulting. And so I'm the cloud native applications practice lead at Saline. I've been architecting web solutions for the past 13 years at Saline. And I've been integrating those solutions with FileMaker through a various number of approaches for each one of those solutions. I like to put it another way. I know a thing or two because I've seen a thing or two. And so I've developed applications for all ranges of companies, for Fortune 500 companies to small mom and pop shops, across all different industries with all different sizes of user loads and demands that those applications come with. Session overview. So before we can kind of get into the meat and potatoes of what the session is going to be, I'm going to dial it back a little bit and make sure we go to the bathroom, we wash our hands of a few sort of bad practices of integrating and designing web solutions. So I'm a little opinionated when it comes to designing scalable web solutions because I do this on a day-to-day basis all the time. So it's a life cycle that kind of spins up for me and then it repeats. I feel like I have a specific way of handling that, and I think that way allows for the most scalability in a web application for a production instance. So we're going to take a look at design-driven development. We're going to take a look at what it is, the problems that it solves for web solutions, and gives us, how it gives us the most scalability. We're going to take a look at JSON data contracts. That's probably a pretty new term to most of you. So we're going to take a look at what they are, why we use them, and how that integrates with design-driven development. We're going to take a look at a number of different data connection architectures. So there's a number of different approaches that we can take to connecting our web solutions with FileMaker. And so those are direct. We can do ESS read-only, direct being direct through the data API. ESS full, there's event-driven architecture, and that's where we're kind of driving to for the session. And of course, we'll dive into event-driven architecture, the why, the advantages, disadvantages, and then we'll do an architectural review. So for each one of these data connection architectures, I've got a diagram, and we'll kind of dive into them. They're all architected out in the cloud. So all the implementation aspect of the web solution is meant to leverage cloud services. And I think I kind of noted that on the description for this. So hopefully everybody has a bit of a understanding of AWS or cloud services and how those are utilized. But I'll do my best to kind of overview that for you as we go through here. All right, so design-driven development. It all starts here, and it really does. We really can't properly scale solutions unless we know the entirety of the data set that is driving the solution that we're trying to develop. As developers, I think we have a tendency to look back on projects and we think, boy, wouldn't it have been great if I knew what I know now at the end of the project about what the data is that's driving this thing. And I do that almost with every project. I do it less now that I do design-driven development when I think through architecting the solution. But it's just a nature of application development. So let me just real quick, oh, I'm on a different slide. So anyway, design-driven development, it's going to be the mechanism that helps us ensure the greatest possible scalability for our web solutions. All right, and then I wanted to read through it. So I'll just read through this definition here. It's an approach to software development that places design at the forefront of the process. It prioritizes user experience, not merely an afterthought. It's a guiding force in product creation. I can't stress that enough. I love the definition, by the way, that I found for this. I think I actually kind of merged a couple of different definitions together. So, and so this method transforms the traditional development process by using design as a tool to learn and define requirements, ultimately leading to better informed and user-centric outcomes. So every web solution that we build is going to start with a vision, right? You have a need, your customer has a need, your application has a need. And in our case, you know, with FileMaker, it's going to be a need to expose that FileMaker data out to some specific customer base. And the problem is that without building the solution with design-driven development in mind, we don't really know all the data that's going to go into that solution, right? We may think we know what data goes into the solution. We may practice something like data-driven development where, you know, we're going to take a look and say, okay, well, I know that I have this entity. I know that I have this other entity. I know that there's some relationships that exist here. But really, we're just kind of making guesses about, you know, what the data is that's going to be consumed by the end user for the solution that we're building, okay? And so, oops, jumped ahead, sorry. Let's see, I lost my place. A few of you are probably rolling your eyes at me right now, but trust me that, you know, data-driven development, in my mind, is a bit of a thing of the past. You know, when I do projects, I'm cycling through the project lifecycle over and over again for new clients. So we're a consulting firm, right? We build solutions all the time. The needs for each one of those solutions is going to be different in every scenario. And we start with what we call a road mapping phase. And so really the road mapping phase is to help drive out requirements for the solution, to get them down on paper and to be able to communicate that back to whoever the stakeholder of the application is.
Lost your audio.
Oh, okay, there you go. Maybe you got another mic coming in.
Put it back in.
Check. There you go. We're on. All right. I was talking road mapping. Yes. Thanks. Coming from another Soliant member here. Appreciate it. So really, it's a visionary process. Like we're trying to get the requirements down on paper, right? But the problem with stopping with that and just leaving your requirements on paper is that it's never actually visioned out into something that you can look and see and is actually tangible for whoever the primary stakeholder for your solution is, right? And the further problem with that is that you're not doing yourself justice. You're not exposing all of the data that you may need in your solution. And again, if we're not exposing all of the data that we may need in our solution, then we're not thinking through how we can make our solution scalable because we just don't truly understand the data that's driving that solution. Okay, so it's an iterative process of reviewing requirements, getting those requirements down on paper, and then making the leap of transitioning those requirements into an actual design. Typically, we'll start with wireframes, and we'll take a look at that here in the next slide. But we're not just stopping at written out requirements, because without the the validation of, hey, your vision that you've defined for what the solution should be as stakeholder A matches the vision of what I've visioned the solution to be. All right, continue on. I'll step off my soapbox here a little bit, for a little bit. So we'll take a look at the benefits of design-driven development here. And I like to call it, I like to rephrase that as design dictates development, okay? Or design dictates the data that goes into the solution. So before I start to go through some of the bullet points that I have on this slide, I just want to call out this little example that I have here is from a client of ours, Needy Meds, and we actually have, I'm going to call out Sam. He's their director of IT, and we have him in the crowd. Thanks, Sam, for letting me use you as an example here. I really appreciate it. All right, so let's go through. Okay, so we talked a little bit about, the interface is going to dictate the data requirements for our solution. So if we take a look at this example here, and I actually have a little, oh, that's going to be really hard to see on the white. That's all right. The other examples that I have are on a dark background, so I'm just going to pause that. So we have a drug quantity search here, okay? We know that there's going to be data that comes through for the drug quantity search. We know that there's going to be a drug name. We know that we're going to need to collect a postal code from the user, a search radius, and all those things are going to drive our search results here. So I just want to highlight that. So another benefit of design-driven development is that it prioritizes the user needs and the experience. So as developers, we don't always tend to have user experience as the forefront of our thinking process when we're developing solutions. So doing design-driven development kind of forces us into that mode to say, hey, how does this solution meet your needs, your experience needs, and is it something that is going to be intuitive and easy to use for you in the long run? And again, all of that iteration that happens continues to drive out additional requirements and expose additional data pieces that we may need in our solution that inform the scalability decisions that we'll make from an architectural standpoint. And we'll kind of see that when we get into the architectural diagrams. And also, again, it provides a visual validation of those verbally communicated requirements. And that's what I was saying there. It continues to drive out requirements where, I can't tell you how many times that I get in front of customers. We review the wireframe requirements, and there's a gotcha moment where they say, "Oh, hey, we totally forgot that when you select this value, this thing needs to happen, or this other piece needs to happen." Right? That happens all the time. So design-driven development just assists us in continuing to expose that. Microservice-friendly approach. And so microservices is probably a concept that's new to most of us here. So as developers, we have the tendency to kind of chain our logic together. We think about things in terms of an interface, and then we solution the code around that interface. And so when we take a look at like the drug pricing calculator that I have here, in a sort of monolithic approach, I used to code with PHP. Right now we use, and I'll talk about this a little bit later, we use API first applications with React and Node for all of our solutions. But with PHP, you kind of lend yourself a little bit more to a monolithic approach, right? Because you have a process that is sort of a request cycle that happens that needs to drive all of the data on your solution. So you're going to put all of that into a single class object, right? And the class object is going to be something like pricing calculator, right? It's something that we name it. And the pricing calculator may have a function that says, hey, give me all the drug quantities that I need to be able to display, or give me all the drug names that I need to be able to display for the user so that they can select this in the pricing calculator. And then it's going to have, a function associated with that class that's going to say, hey, do the search. Search all the quantity, search all the drugs based on the drugs that I've defined, and the quantities that I want, and the distance, all of that, right? And so it gets put into this, what I call like a monolithic class structure, okay? The problem with that is that's not scalable. When we build multiples of those on top of each other, that becomes less and less scalable. And it's harder to pull out and say, well, actually, it would be really nice if I had that list of drug names available somewhere else in the application. And it would be really nice if I didn't have to instantiate that whole big pricing calculator object to get at that information, right? So what we do instead is we look and we say, hey, we want to take a microservice friendly approach to this. And we want to say, okay, I'm going to create an endpoint. That endpoint is an API endpoint. It's going to be RESTful based, and we'll look at this a little bit. And the only responsibility of that endpoint is to populate that list of drug names that goes on this page. And so then we have a separate endpoint. So we're going to have another endpoint that's going to run the search pricing. And if we had like postal code validation or something like that, right, we create a separate service to handle all the logic that's associated with that validation, instead of sticking it all together in one master class that does all of that. And that approach is different than, a lot of us have probably learned if we are, if we sort of took computer science degrees and had that background of, hey, everything belongs in a class, and classes have related functionality. Well, in terms of scalable web solutions, the approach is totally different. Classes are a thing of the past. Everything is microservice oriented, so that you can extend each one of these independently and not have to worry about dependencies between the different services that you have. All right. And then overall, this is going to reduce the data ETL complexity when we combine this with JSON data contracts. And so JSON data contracts is what we're going to step into next. All right. So thanks to design-driven development, we now know what the data is that we're going to need to feed into our solution. And we now know that we want to break that data down into different microservices that are going to support the front end of the solution. And that's going to allow for a level of scalability that we didn't have before. So now we need to talk about how we're going to send the data between the applications. How we're going to send the data from typically our FileMaker solution to our front-end web solution that we're building on top of that. And how are we going to ensure that the data that the web solution is expecting is the right data that it needs, okay? And also, how are we going to ensure that it's the right type of data that it needs? Because if it's not the right type and it's not the right data, our solution is going to break. All right, so enter JSON data contracts. All right, let's see. So what are JSON data contracts? Well, really, it's an abstract concept that is built on top of RESTful API architecture. So hopefully most of us are familiar with RESTful API architecture. And so this is just kind of an example that I've got over here on the right, and I'll break this down. I actually can use my laser pointer now, make it useful. So RESTful API architecture is what our data API supports, right? That's the communication method that we have to get data in and out of FileMaker, one of the communication methods. And so I'll just kind of break down what we're looking at here real quick. So we've got our JSON object here. And so if you remember in our previous slide, we had, we wanted to get the list of available drugs for our pricing search calculator to make those available in the select. And so we've got our base JSON object here. So JSON objects start with a little curly brace, they end with a curly brace. You define the parameters in this structure here with the double quotes, and it points to a value. And so you can see the parameter here starts with, and the value is B. We can then further build on the JSON structure here. We can define things like arrays and then sub objects of the array. And that's pretty much the basic structure and of the JSON object itself. And so JSON is really, the point that I'm trying to bring home here is just that JSON is the data that flows across the wire when we're doing all of our communications between FileMaker and our solution. The other thing that I'll point out here, just in terms of RESTful data structure, if you're not familiar, is that you'll see this little post up here in the top. So the post is the method for the protocol request that's happening, right? So we have post, we have get, we have put, and basically what those mean are, hey, I either want to insert data into a system, I want to update data into a system, or I just want to get data from the system. And so typically you'll see in the URL here, this is the endpoint that we're trying to get information for. You can see that this is a post. So I want to put data into the system. And this is the data object that I'm putting into the system. And then we have a response that happens as a result of that request. Okay, so that comes along with a response code. You can see that the tool that I'm using here just has, a time that was associated with that request. And the size of the request. That's not super important here. Just know that most of your JSON requests, when you post, when you put, are also going to come along with a response that is going to be the data that you're trying to get out of the system. All right, let me keep going through my points here. I jumped ahead of myself here a little bit. So obviously it's written in JSON. That's the structure we talked about. It's controlled with REST. And then it's validated with schema validators. So schema validators are another concept that you may not be super familiar with, but are of the utmost importance for ensuring that the data that we get is the data that we think that we're going to get, okay? So you have our JSON object here, right? And, or actually rather this JSON data object. So I make a request to the data API. I get this response of drugs here. And in terms of the front-end solution, I need to really ensure that this ID parameter is of type string and that it's also a UUID, okay? My application depends on this. So we leverage what we call schema validators in JavaScript. And the schema validator is a way for us to define what the JSON structure is that's coming into our application. And it gives us a way to control what the actual parameter types are that are going to be coming in. So we have strings, we have numbers, floating point numbers, all those different types. And then we can actually add complex logic on top of that with our schema validators. We can say, hey, there really needs to be, if this value over here is of false, then I'm expecting to get an additional object in my structure. So you can add complex logic on top of that. And without schema validators, especially with FileMaker data, we run into a lot of issues. So imagine, if you will, the scenario where you have a user that is working in Microsoft Word, and they copy a string, a sentence string in Microsoft Word, and they've pasted that into their FileMaker solution, into a text area. And it's now copied and pasted a bunch of HTML content from Word that is not data that we want, and it's actually going to break our solution. Without schema validators, we cannot ensure that we're not going to encounter that type of data. So it really helps to expose those data problems early on in your testing and help the solution break early and be able to identify those quicker rather than getting something into production and having your production instance break. All right, let's continue on. Oh man, time is running quick. Come on, Steve. All right, JSON is platform independent. I think most of us know that, but JSON is what allows us to integrate our solutions with all sorts of different APIs and services out there. It simplifies those integrations. When I think about data in terms of a JSON structure, it really helps me break down, okay, why am I we tend to overcomplicate our data structures, right? And so JSON just, for me, really helps simplify, the data in outflows that happen between applications. We improve the data validation. I kind of talked about that, right? Like the issue where we've got different characters that come through that we don't see in our text areas and that we're not expecting. And so using JSON with the schema validators can really help that, and putting it all into a contract also assists in that. This is scalable. Just inherently, JSON is scalable. Again, we break things down into microservices. Microservices are scalable, they're extendable. All of this goes together. We reduce the data in outflow friction. This is a piece that I experience on a day-to-day basis, but as a front-end developer, I have different technologies and things that I have to deal with my code. So one of those things is TypeScript, okay? And so when I put a contract together with a FileMaker solution, typically it's going to be a FileMaker developer, I'm saying, hey, I need the data that you're returning to be in this structure, okay? The problem is that FileMaker does not have the capabilities that I have in JavaScript-based languages like Node to be able to do the mapping, to match the data structure in that exact format. And I want it in that exact format because I know that that exact format matches the interface that I've defined, okay? So when we put things together in a contract structure, it allows us the ability to very quickly point to and expose the mismatches in the data structure that I'm expecting. If you don't have these JSON contracts and structure in place and defined and communicated between both sides of the equation, the providers and consumers, then you're going to constantly run into data mismatch issues, data structure issues, and it's nice to have this defined as, hey, something to point back to and say, hey, here's what we said we wanted it to be. Let's work on getting that in that structure. All right. Oh, looks like my last one wasn't highlighted there, but the easy to document APIs and share. So once you define your data contract structure, you can put this into a number of different control solutions. So we use Insomnia to kind of define all of our data contracts. And then we can take those data contracts, we can put that into a code structure. And then once you have that, it's very easy to kind of export those into documentation for your API. So there's a lot of tools out there in the market that will just take this JSON structure, this well-defined JSON structure, and then allow you to easily convert that into consumable API, so you don't have to go back in and write the documentation for all the API endpoints that you've defined, because all of the requirements are actually defined in the contract itself and in the control mechanism of the RESTful API endpoint. Okay, I promise that was a lot on JSON data contracts, and I promise it's going to make sense when we start to kind of look at our architectural diagrams and we take a look at how the data flows between everything. All right. So before we get into the data connection architectures, I just want to do a quick overview of how Reliant solutions all of our web applications. And so everything that we build now is an API first application. And to break that down real quick, API first applications have a middleware, which is your API. It's going to sit in between your FileMaker solution and the actual user interface that the user is using. So for the user interface, we're utilizing React, and that's a JavaScript-based framework. It compiles down very nicely into just static JavaScript that we can host in the cloud. And then that solution allows the interface to make requests to our API middleware, which does the legwork of communicating with FileMaker's data API, or as we'll see, any of the other services that we put into our event-driven architecture. All right, here we go. This is our most basic direct data architecture diagram. And so I'm gonna start breaking this down for you, and so you can see and understand what we're looking at. So it's hard to read, but this is AWS region, right? So everything that we're looking at inside of this dotted square is AWS services, okay? So all of those things are sitting in the cloud. And so we have our local developer, right? And we're building our React and Node applications. We put those into a version control system. Those are then deployed out to the AWS services by way of a code pipeline. And so that's continuous integration, continuous delivery architecture there. And so what happens is our front end, the React solution, is compiled into JavaScript. It's put into CloudFront, which is really pointing to an S3 bucket. So as a user, I open my browser, which is this up here. I make a request to the browser on the solution. The solution then says, oh, hey, this is just running the front end React code. And that is hosted in CloudFront, which is actually an S3 bucket. And this piece alone helps us scale out our web solutions, because the S3 service itself with CloudFront is locally distributed out across the country to all sorts of cached endpoints. So a user makes a request to the website. Instead of that request going to a singular EC2 instance or a singular server running the website, it's distributed out across a cached network of buckets that the user then is going to get a much quicker response for than if they had tried to go to a singular instance. And so as we flow through the remainder of this, then I want you to think about the data flow in terms of the API, okay? So that's a front-end request. So that's hey, I loaded up a web page. The web page doesn't interact with the API. It's just showing me static information. And then we go into web page loads up, user clicks a button, that's going to make an API request, okay? And like I talked about before, that API request is going to be JSON data flowing through the API solutions here. So the API request comes down, it's now made its way into the cloud, and we hit a load balancer. Okay, this is also important for scalability. So our APIs are going to see the heaviest demand. And so typically our APIs are also going to be our logic centers, right? So they're going to be doing more things than what the front end of our solution is going to be doing. So we may need to load balance this. And having this in place is going to ensure that the solution can scale out if it needs to. What it does is put all of our JavaScript, so this is our API right here. This is our Node.js API. You can think of it a lot like a FileMaker data API, right? It's a RESTful service. And so our JavaScript flows through the load balancer. The load balancer then pulls up Fargate here. And so Fargate is our containerized service, okay? So in order to support all of this code pipeline and continuous delivery functionality, our application is broken down into containers. And so when the request flows through the solution here, it hits a specific container that's a virtualized container, okay? And this all runs serverless. I don't have time to get into the full technology here. Feel free to hit me up after and we can talk through this. But ultimately what happens is once it hits that container, it's really hitting the code base that we wrote for our API, okay? And so then the API comes in and says, okay, I got an incoming request. And the first thing that it does is says, hey, is this a cached request? If it's a cached request, then we're going to use Redis cache. And so Redis cache is an AWS service that allows us to cache our responses. It's pretty scalable in and of itself. You can load a lot of information into the cache. You can load tables. It can do a numerous amount of things, and it just adds another level of scalability for us for our web solution in the event that we need it. If it's a cache miss, so I don't have this cache, then I'm going to do a read directly to FileMaker's data API. Okay, and the JSON data contract here is just sort of an abstract, like, hey, remember that we defined a specific data structure for how the JSON should flow in and out of the data API. And so this is going to happen for read and write operations against the FileMaker database. How are we all feeling? Everybody with me? Getting a little too deep? Maybe not. I don't know. We'll see. All right. We're going to continue on in the interest of time. So some of the advantages, disadvantages is that you have consumer-provider friction in this scenario. So if you're not utilizing data contracts, even if you are utilizing data contracts, there's going to be friction between you as a provider of your FileMaker data and me as a consumer of your data, because it's not going to be in the format that I want it to be. Even though in an ideal world we think, hey, we could just define this structure and we can all agree that it should be in that structure, it doesn't always end up that way, okay? So there's going to be friction. If the data API is down, your website's down. That's not good. That's one of the things that this event-driven architecture will solve, and we'll get to that. Data API usage limits. I don't encounter this a lot, and I am certainly not an expert on all the current usage limits for the data API, but it is license-based to my understanding of how much data transfer you can get in and out of the data API. So that's a consideration. Scalability is reliant on the stability of the data API, okay? Again, I work with a lot of different customers, a lot of different FileMaker solutions. Those solutions can be homegrown solutions that have been upgraded since earlier versions of FileMaker. And so there could be stability issues with the database itself. And although the data API is running as its own service, ultimately it's reliable on the stability of the underlying database. And so when you run into high request loads, this can spike the the core processes on the machine, and you can run out of memory, and you can cause the database to crash. There's a lot of things that can happen, right? And so this architecture approach is prone to those issues if they exist. Request latency. So say I've loaded all these services into the cloud, but for whatever reason, my FileMaker database needs to be on site because of data security requirements for whatever reason, right? I can't put my FileMaker solution in the cloud or server in the cloud. And so you're going to incur request latency that's going to happen for your requests between those two different data points, right? Better if you can get it in the cloud, but ultimately that latency is going to exist. Again, I've talked about this a lot. It comes up a lot, prone to data type mismatches. When I encounter the types of data type mismatches from FileMaker, then I'm typically going to just code around those in my application just because it's easier to map the data. Another issue that I've run into a lot is that the standard API response tends to bury the actual data inside of multiple subarrays of information, right? And so there's going to be additional time necessary for you to map that data out on your web solution into the structure and format that you want it. It's just easier to do it on a JavaScript-based solution or whatever you're using for your web solution than it is to do that legwork in FileMaker. That was complex data mapping. Sorry. All right. Advantages. It's low cost. Doesn't cost a lot to run, the services. That cloud infrastructure that we looked at, there's not a lot of services running. I would say that, on average, what we just looked at is probably like a $50 to $100 a month run rate, probably less than that. Low complexity, again, not a very complex diagram. And it's low maintenance. All right, moving on in the interest of time. Okay, so our next architectural possibility that we have for our scalable web solution, and this makes us a little more scalable, is ESS read architecture. Okay, so that's the external SQL sources. And so, we've already walked through our data flow that we have. And now we get past the cache layer and we have a separate logic point here. So is this a read operation to our database? If it is, then instead of running the request through the data API, we're actually going to hit a local MySQL database in RDS. So RDS is Amazon's relational database service. And so there's a couple of benefits of that. One is that MySQL is pretty good at read operations. And you can then increase the availability of the database through MySQL and allow more users to make more read requests than you could through the data API. Typically, this isn't going to be an issue unless you're talking like thousands of requests, in a minute. Okay, or you may not need to consider this. But the other benefit of this data architecture structure is that RDS can scale out horizontally itself. Okay, so you can turn on read replicas of RDS. I just had an instance with a project where we set up this structure. We wanted to ensure that the initial RDS database that they were reading from wasn't going to be overloaded because it was being consumed by a number of different resources. And so just being able to replicate that database into another read replica and then have this new solution that we're building on top of that database be able to read from the read replica allowed us to scale out without having to worry about the initial load that was on that other RDS database. And then, of course, any write requests still go through the data API for this architecture structure. Okay, let's go through some advantages, disadvantages. So the sync data structure limitations strongly encourage to keep the same data structure. Basically what I'm saying here is that you can't change the data structure in your RDS database from something that's different from the underlying FileMaker data structure, right? Like it needs to stay the same. There's maintenance with sync. Advantages is that the data API outages only impact the write operations. I'm sorry. No, I did have that right. Yeah, my brain is working backwards. So now if FileMaker's down, we can still read from the database and we can still show our data to our web solution. The reads are scalable. We talked about that we can scale out the RDS instance. We can create new read instances. Okay. Continuing on, then we've got ESS full architecture. So very much like what we saw before, except for now, both of our read and write operations go through our RDS database. Okay. So the sync is happening for both read and write. Okay. Disadvantages for this, there are a lot of oddities when it comes to two-way syncing with FileMaker, and I see a lot of smiles in the crowd right now, so some of you have probably experienced those. There's data caching, manual field adds. It's eventually consistent data. Eventually consistent data means that when you have a write operation, that write operation may not make its way back into the FileMaker database immediately. So you've got a potentially 2-minute cache window here without flushing it. And, you know, again, diving back to the design-driven development, you know, you expose those needs when you do the visioning, when you document, when you put your visual interface in place. It'll become very apparent whether or not that's an issue for you or whether it's not. It may not be an issue. All right. Advantages. The data API outages no longer impact your end users. Everything is being read from the RDS database. Okay. We're no longer directly hitting FileMaker's data API endpoints anymore. You have scalable reads and writes. That's just inherent, again, with setting it up in an RDS database. It's a more scalable option. Okay, here we go. We're finally there. Event-driven development. So event-driven development, it's characterized by an emphasis on event handling. So actions are triggered by specific events. This enables a more dynamic and responsive system. Event-driven development facilitates disconnected data systems. They scale horizontally. We decouple producers and consumers. That's, you know, our front-end web solutions and our FileMaker solutions. And we separate the ownership of the data by domain. All right. So this, yeah, it's a little complex to look at and take in at first, but we'll break it down. So the first thing I want to talk about, though, is the event-driven aspect of this. And actually, the event-driven aspect of this is the least complex piece, okay? So I think most of us are familiar with CRUD operations, right? And so if we take the R out, we're just left with CUD. And I want you to chew on that for a minute. That was my joke. That's the best I got. I'm a dad. All right. So anyway, CUD events are what you want to consider when we're talking about event-driven architecture, okay? And so let's start to break this down a little bit. So a CUD event is a create, an update, or a delete. And what that's going to do is going to need to be handled in your FileMaker solution. And so anytime a piece of data is modified, that is a piece of data that is exposed to your front-end solution, you're going to need to make an API request to this Node.js middleware that happens here, okay? And we've got a bit of a disconnect here now. So basically, that's a time disconnect, right? There's no continuous update that happens when when an event happens in FileMaker. You need to manage that. You need to make an API request to the middleware API to do the data update. And then what happens is, so let's say that I make a read request or a write request, then the middleware then says, oh, okay, I'm going to, if it's a write request, I'm going to invalidate the cache. That cache that was there is no longer valid. And I'm going to write that out to the RDS database. I think I have a later data point on this, but I'm going to go ahead and call it out now. One of the benefits of this architectural approach is that now I'm no longer locked in to the normalization that is defined in my FileMaker solution, right? So what that means is, as a front-end developer, I'm going to structure my data differently than what you're going to structure it in your FileMaker solution. And rightfully so, right? It's a totally different interface that we're building out and trying to support for our customers or whoever our consumer is of the solution. And it should be architected independently of any decisions that were made in our original FileMaker database structure, okay? And so this approach allows me to basically say, oh, hey, the API is making the write request to my database. Now I have full control over what I want that data structure to look like in that database. I'm not locked in. If it's a read request, again, FileMaker has to make a read request to the API. Say, for instance, you want to update a piece of data that's being exposed to the front-end solution, but you're not sure if that data already exists in the front-end solution, or you're not sure what the state of that data is. You may need to make a read request to the API solution to ensure the state of that data. And so the read request comes in. It says that it's a read request, and then it's going to read from the RDS database, and it's going to return there. So that's your CUD events that are happening in FileMaker, right? And then you have your events, you have your front-end requests that are happening from the website, and that data flow is also a little bit different than what we looked at before. And so what happens here is, specifically what's different is the write request structure. So in order for us to be completely disconnected between systems, we need a mechanism to allow write requests to be captured and held until such a time as the FileMaker solution is available to process that request into itself. Okay? So that's this whole giant thing here. Some of you might be familiar with Align sidecars, and really that's what that structure is, okay? So I have a JSON write request that comes in. It's a post that comes into my API. The API says it's a write request, and then it comes down here and it says, oh, hey, the first thing I need to do is hit an API gateway endpoint. Well, you can think of that as another RESTful endpoint that needs to be hit. And what happens is then that triggers a Lambda service that will throw that write request into an SQS queue. Okay, so now our write request is sitting in a queue in the form of a JSON structure that it's just waiting on FileMaker to be available to process the request. And so then we have another Lambda service, and all these are kind of chained together. They're all, in Amazon allows you to kind of chain these events together so that you can just say, hey, when an event happens, try to do this. If not, default back to some specific state. And so this Lambda function is being triggered, which is our function that writes to FileMaker through the data API. And so that write request sits in the queue. The queue tries to process the request. It tries to make the connection to the data API. If the connection's up, great, we make the request. If the connection's not up, then that's fine. We leave the item in the queue so that it can be processed at a later time. And so this provides us the most scalability for our solutions because we're really not dependent on any service being up at any given time. It's sort of what I like to call infinitely scalable, right? This can support data loads in excess of whatever you can think of. So it's what was that?
Black Friday.
Yeah, Black Friday data solutions, right? All right, I've got 5 minutes left. I've got some bullet points that I just want to go through with this real quick so that we can talk about them. Event-driven architectures, they're eventually consistent data. Again, primarily the write requests for that is what we're talking about. The write request goes into a queue. That queue is processed as quickly as the connection to FileMaker is available, but ultimately it's eventually consistent, right? There's milliseconds of delay that can happen there. It could be even longer than that. But important data. There's more moving parts. So we saw that's a pretty complex diagram. You've got a lot of different cloud services that are running to support that. And that's just the nature of that architecture in general. Cost. More parts, more cost. Although, I'll be honest, most of the stuff that we're looking at there is serverless technology. And in AWS, serverless technology has free tiers that meet the demands of most of our applications. So it's, it varies. Data seeding for large sets requires consideration. So because now all of my writes to the database are happening through the API, I don't just automatically have the data that's available in FileMaker in my solution, right? And so when you're getting this up and running, you need to seed all of that front-end data that's going to support the web solution initially through the API endpoints that are available. I didn't see it. Okay. And this decoupled data connections, again, that's a major advantage. Everything's decoupled, right? If one service isn't available, not a problem. The site continues to run. It's horizontally scalable. All the services that we looked at scale out horizontally indefinitely. I mean, within Amazon's capabilities, right? Pick your normalization path. We talked about that. As the front end, your front end solution can have a completely different database structure than your FileMaker solution. And data type consistency and exposure. And two final ones. Auto-generated API documentation, we talked about that. We also talked about the consistency and structure. And then obviously it's a maintainable microservice approach to scalable web solutions, highly available. All right. I did it.